Hello everybody, this is Todd Frazee and this is the video tutorial for the S60-139 CAD work for the drive post. This is a steel part, so that's why it's rendered in gray. It's made out of mild steel, and there are two configurations of this design, one where it's welded and the other one where it's bolted together. So that's the reason its material is steel. And this is more of a prismatic part, so you're going to be making this all with extruded cuts, hole wizard, things like that. Alright, so let's go to the drawing. And we see that we have this 11-degree taper, 1/2 inch thickness. We have a hole that goes all the way through that's 1/4 inch, but then it has two high tolerance counterbores on either side to accept press fit bearings, and the axle part presses into those two bearings with the flywheel on one side and the crank on the other, and it spins with the bearings. Okay, and we have some tapped hole, we have a tapped hole, and then we have two dowel pin holes that straddle it, and they're designed to have a press fit so that the 1/8 inch steel pins press into those two holes. And then on the mating part, there are 1/8 inch holes that are slightly oversized that slip fit, that locates the part, and then the bolt holds it everything together. Alright, so we're going to move on to the next step here. So let's open up SolidWorks. And we're going to create a new part file. And we'll make our planes visible. And we're going to sketch on the front plane as our primary. And I'm going to start with a circle. I'm going to put that circle up at the top. Okay, that's going to be top of our tapered part. And make sure it's snapped on the plane that intersects. And then we're going to draw a line that intersects the base plane and comes up. And if you hover close to the circle, you'll see a yellow tangency symbol show up. We want it to be tangent. So hit escape, and we're going to duplicate that line on the opposite side. I found it's easier to get the tangency symbol to come up if you're not trying to draw the endpoint to the circle. So you go past and then we trim it. Alright, so why don't we go ahead and do that. We'll trim off the ends of those little pieces. Okay. And I guess we could trim off the center too. Okay. Now, we want this to end up being symmetrical. So we already have the center of the circle symmetrical. If we put in a relationship between the two endpoints of the arcs so that they have to be horizontal, that's going to force the symmetry with the angle. Okay, and then we're going to put in our angle, which according to our drawing is 11 degrees. So we're going to type in 11 degrees. Okay. Alright, now I need to make a line from end of each of the angled parts, and we should get an enclosed volume. Now the dimensions are all off, but we've got basically our perimeter. Now we just need to put in dimensions. So we're going to put a dimension on the radius here, and I'm going to go back to our drawing, and it's 240 thousandths radius. 0.24. It's going to get significantly smaller. And then the other dimension we need to constrain is however it's dimension to the height, and it looks like the overall height and the height of the center of the hole has a different level of precision. And that is partially because this could be made as a casting. So you wouldn't want to hold the outside position as tight as where the actual hole is. So we're going to go ahead and use this 1-inch 830 for this arc, but we want to make sure that we don't make a concentric relationship between the higher precision holes and that arc, because in reality we have a lot more freedom of tolerance on the arc, and they don't have to be concentric for the function of the part. Okay, so 183 is our height. We're going to go from the base, and then we're going to hold the shift key down, which allows us to select the tangency point of the arc. Otherwise it's going to go to the center. So we're going to do 1 inch 0.830 thousandths. And we get our overall height. Okay, so that's our base extrusion. And in this context, this time I want to have symmetry set up with the overall thickness of our extrusion. So we're going to hit accept, and we're going to highlight the sketch. We're going to go to features. We're going to do our extruded base, but instead of doing blind, I'm going to say mid-plane. So it puts the center of our extrusion on the plane the sketch was drawn on. And then we're going to put in our thickness of a 1/2 inch. And so their overall thickness should be a 1/2 inch divided on a midplane. Okay, and we're going to accept that extrusion. And now we have our base extrusion for the part. Now you could choose to approach this by doing a variety of different things. We can put the hole through the front face, or we can put the holes in the end. I'm going to finish off what's in the front view, and then we'll work on the back view and then the base. So we're going to go to sketch, and we're going to select the front face of the part itself and the sketch tool. And let's look at the model straight on. And I'm going to draw a circle, and I'm going to place it so it center lines on the vertical axis. But you notice I tried to avoid having my selection. I made it intentionally not concentric because I don't want to build that relationship in. Because the way the tolerances work out, that hole doesn't have to be concentric. Okay, but it has to be on center line, and we need to put a diameter on it, which was 250 thousandths. So the diameter is not that critical. And then we need a dimension from the center of that circle to the base. We're going to click off to the left, and we're going to reference our drawing. Our drawing says it's 1 inch 594 thousandths. Okay, and we're going to change the number of decibels so we can significant digits so we can see that. And we've got our 1/4 inch hole. Okay, so now we're going to rotate to a 3D view so we can see what's going on. We're going to do a feature. We're going to do an extruded cut. It's going to be through all. And we're just going to go the one direction and hit accept. And there's our 1/4 inch hole. On our drawing, concentric to that hole is a hole that's 375 to 373. So halfway through the tolerance on that is 374. So we're going to make the one on the front face by doing a sketch. We're going to pick up on we're going to do a sketch. We're going to do that on the front face. Then we're going to make a circle. And we're going to pick up on the circle until you see the little dot show up in the middle. And then you're going to move over and select that dot, which makes it concentric. And we're going to draw our circle, and we're going to put a diameter on that circle of 0.374. And let's expand our tolerance to 3 places. And we'll accept that dimension. We have a fully constrained sketch. We're going to exit the sketch. We're going to make sure it's highlighted. We're going to do a feature. And we're going to do an extruded cut. And the depth of that extruded cut, according to our drawing, is 115 thousandths. So 0.115 is the depth. And we're going to accept the depth. Okay, that gives us a 115 thousandths counterbore on the one side. Make sure you save. Now we need to make one on the opposite side. And we're going to use a mirror command. So we're going to mirror the whole feature. So if we select mirror, it asks you what plane or face do you want to mirror about. And because we made our part symmetrical around the front plane, we can use that as our mirror line. Now it's asking what features to mirror. Now you can actually just select the feature, but to ensure you have the feature you really want, I would select it on the feature tree, and it'll show a preview of where it's going to go on the opposite side. And then we're going to accept the mirror, and now we've just created the counterbore that's identical in size on the opposite side of the part. Okay, make sure you save. We're going to now roll to doing the work that's on the bottom of the part. So we want to physically look at that part in the same orientation it would be in the drawing. We got the front facing the front plane, and we want to draw our dimensioning scheme just like it is on the drawing. Okay, so we're going to do a sketch, and we're going to select the bottom of the part. We're going to look at the part normal to our sketch plane. And we need to make sure we dimension these holes the way it is on the drawing. Okay. So what I'm going to do is set up a sketch first. We'll use a combination of the hole wizard and extruded cuts to actually make them. Okay, so I'm going to draw a construction line. We're going to make that construction line horizontal. Okay, so we're going to use the point command, and we're going to hover over the center of our center line. We're going to put that point right on the midpoint of the line. Now, that is for us to use the hole wizard on that point. Now we're going to draw a circle on either end of our center line, and that is going to be for a standard extruded cut for our 2 dowel pin holes. We're going to highlight both of those circles, and we're going to make them equal in size, and we're going to dimension one of them. And according to our drawing, the dowel pin hole is a 123 to 124. So we're going to shoot right in the middle. It'd be 123.5 for its diameter. And let's expand that to 3 decimals. And now we're going to put in dimensions. Okay, so we got our dimension in our drawing. Shows we have a dimension going to the center hole. So we're going to go from the center hole to the edge of part. We're going to drag that up, and our dimension is going to be 394 thousandths. We'll expand the tolerance to 3 places. And then from the top edge, the dimension to the center of that hole is 250 thousandths, a quarter of an inch. Then they have a dimension from our center hole to the hole on the right as being 250 thousandths. Alright, so let's exit this sketch. And we're going to look at it in a 3D view. We're going to shut off our planes. So we hide the plane so we can see just our sketch. Okay, so I'm going to go to Features, and we're going to make the hole in the center first. So we go to the Hole Wizard. We still have a threaded hole, and it's going to be a tapped hole. And we want 632. It's going to be a blind hole. And our depth of our threaded hole is a 1/2 inch, so 0.5. Okay, and then we select the face of the position of the threaded hole. And it's coincident with the we select the point. And accept. And we have our 1/2 inch deep 632 hole, tapped hole. Alright, so we're going to exit that command, and we're going to use the same sketch we used here to create the two dowel pin holes on either side. And so we're going to go to Features, Extruded Cut, and we're going to expand out our sketch, and we're going to select the entire sketch. And it's a blind depth of 250 thousandths according to the drawing. And we'll accept that. And now we have our two dowel pin holes for press fit steel pins. Alright, we pretty much have this part done. All we have left is a fillet to put around the outside. So if we look on the drawing, it says fillet radius is 0.03 typical. So that's typical where they're shown. So we're going to go to Fillet. Okay, Fillet. We're going to select the items to fillet, which is a chain of the top and the bottom. And we're going to set our fillet at 0.03, which is 300 thousandths. Sorry, 30 thousandths. And we have our fillet features. Keeps it from being a sharp edge. Okay, that's it. That is everything you need to develop the S60-139 part. Now we're going to move on to a similar steel part. It has more features in it, quite a bit more complicated, but hopefully that'll go pretty smooth. And it uses the same pinhole patterns that are in the bottom. Alright, thanks a lot, and I'll see you on the next one.